next time I try. And even if I still can't do it yet, you know that I'm gonna stick to it. Yes! It's all about going through it, and I'm gonna tell you why. Whoopsie! Whoopsies, I made a mistake and it's okay. It's okay! Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay! Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay! Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too late. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love, please don't give up on me.
at it. Is it work? Oh, there we go. We're back at it again. Another day here in 100 Days of Rootkit. I hope y'all are excited to continue our journey. Today, we're going to be dabbling a little bit in machine learning. So I hope y'all are hyped. I know I am. All right. So let's get to it. Let me go and switch over the music here. And we also gotta obviously fix the stream a little bit. We're looking a little naked here. We did a stream earlier today. If you didn't see it or you weren't there, make sure you go check it out. It was in regards to what do you do after a boot camp, right? Particularly for people in our audience who go to a scammy boot camp and are then just left to dry because you're just screwed over. We give you next steps on how to salvage what has just happened to you. All right. Alrighty. It's a good watch all around, even if you don't do even if you didn't do a boot camp. All right. Even if you're watching 100 Days of Rootkit through, or you're trying to do your own journey, I highly recommend watching it though. All right, let's go ahead and make our switch over here. We got to finish up our intro, then I'll fix up the stream. If you don't know, we are a Rootkit nonprofit organization here in the US of A. Don't go to college. Don't go to any other boot camp. All right, just watch all 100 days. Get certified. That it's that easy. Then get a job. Not that hard to understand, right? It's really that easy. Go over to our blog. We have our last giveaway going on right now. All right. Enter to win the giveaway. All right. Enter to win the giveaway. It's free. We're giving away 10 different pieces of merch, all right, to 10 different, well, sorry, more than just 10 pieces of merch. We have 10 different winners, all right? So enter to win. We got 6 sweaters we're giving away. We had a bunch of stickers we're giving away and the pins, all right? It's free. Just click the green button and enter to win, all right? How do you get more entries? Subscribe to the YouTube channel, follow us on Twitch, etc., etc. It's just that easy. On top of that, there's a link in the description of the video, and if you're on Twitch, somewhere down below, where you can click that and donate today. We are a charity, so if you like avoiding taxes, hey, start avoiding your taxes. Donate today. Depending on how much you donate, you can unlock certain rewards like our epic stickers, our collab t-shirt, and our epic sweater. All donations are matched 1-for-1 for the first 10,000 donations. So every time you donate, it's like donating twice as much. And we have pillars along the way, like stream for 24 hours straight, shave my head here live on stream, and the one no one wants to see and no one cares about, all right, shaving my beard, all right, no one wants that, all right. So let's go ahead and move on, shall we? Let me go ahead and fix our stream here a little bit. Let's turn this back on. That's not the right one. There we go. And we need this, and then I gotta move myself up right there. There we go. There we go. Now we're back on the road. Any comments, questions, or concerns before we... Let me pull up the chats here. What's up, Northeus? You were here earlier too, bro. Welcome back. Any questions, comments, or concerns before we continue our journey today? Right, before we continue our journey today, it's about to be an epic one. Oh, I guess before I forget, we are also in the Discord. So if you are a volunteer, aka a champion, a Patreon member, or a Discord server subscriber, premium member, whatever it goes by, you can join the events chat and chat away. You know, right? You can go ahead, instead of typing normally, you can join and talk. Right? You can talk and ask questions at any time, right? So make sure you do it. Damn right, am a dev. That's right, bro. All right, let us continue on, shall we? So let's go ahead and mark out this checkbox because we finished up yesterday. Where's my cursor at? We finished up yesterday content posting with and without images. All right, we completely finished that. So we are done with that. So we are on to automated image scanning and detailed extraction. All right. So we're going to use AI to go about this, and we're going to show how easy it is to use machine learning. Literally super easy. There's no excuse you're not using it in your products. All right. So let's go ahead and see here. Let's first make sure, let's see what branch we're on. So we're on feature posting. So let's go ahead and, I'm just going to commit this little change right here. Marked, what is it? Image and text posting as complete. Git push that up. We're going to merge this into dev. So we're going to git checkout dev, git pull. All right, let's go ahead and merge this into dev. Git checkout. No, not checkout. Git merge. And the branch was feature / posting. And tag no tag ff. Then we're going to git push that up. Cool. Now let's go ahead and git checkout to a new branch to make this new feature, which is the machine learning. So we're going to do feature, and we're going to do auto tagging. All right, we're going to call it auto tagging because we're automatically going to make tags for things they upload using pre-trained machine learning models. All right, so let's go and do a git push just so this branch is pushed up to GitHub. And whammo bammo, we are good. All right, we are good. So let's get into this. So there's a lot of ways we can go about adding machine learning applications to our products we're trying to develop or your projects you're trying to do. All right. It's very, very easy. Lots of people are spending lots of time investing money in machine learning and making it open source. Honestly, one of the most surprising things to me is how much people are open sourcing their pre-trained machine learning models. It actually boggles my mind because it's not cheap. Some of these models that are available cost millions of dollars to make, and they're giving it to you for free. It's quite mind-boggling, all right? It's quite mind-boggling. So there's a couple ways we can go about this. One, a lot of you guys may be familiar with YOLO, right? YOLO v5, that's where we use in the aimbot. So I would imagine a lot of you guys are familiar with that. Now, we went with YOLO because it's really fast, right? That's the whole point of even the name YOLO, is it's very fast. It only looks once and it goes through images. It's not really the most accurate one. When we're making this project, it's not meant to be real time like an aimbot, all right? Like an AI aimbot. So you can go with something that's slower, something that takes more time to process because we're not worried about it being real time, all right? So there's multiple ways you can go about getting yourself an aimbot. Oh, I'm supposed to be using this. One is if you attend our machine learning courses, or if you go to the machine learning section of our what do you call it? Of our Discord, we have pins. We have pins in there that you can check out and see helpful, useful links. So major place to go, number one, just your de facto should always be Hugging Face. It's the GitHub of machine learning models. You should definitely go here and explore it. All right, it's super easy to use. It's a wrapper on top of PyTorch, and you pretty much go right here. You find what you want. We want to do object detection, so we click on that. Bam, here's a bunch of object detection models we can use. How difficult is it to set up? Well, we'll click on one, and here's the code. Not that difficult, right? Not that difficult at all. And there's higher accuracy models. I think 101 is just for larger images. Usually higher number means better, right? Means it can be more accurate. Oh gosh, excuse me. But there's lots of the ones here. There's some YOLOs. You can use YOLO v8 if you want, all right? Just because they're meant for being speedy and not as accurate as other models doesn't mean you shouldn't use it. You can use anything, right? You can use anything you want. It's totally up to you. Now, after this, you definitely want to do your own self-exploring, and when you find things like YOLO v8, all right, follow their creators. So Ultralytics is the creator of it, and they have their own Ultralytics library now. So you can also use this library, and it's packed with a bunch of different models that you can utilize, and it does everything from detection to segmentation. Let's see here. The next thing would be Torch Hub. So PyTorch themselves has something called Torch Hub. It's kind of sad All right, it's kind of sad compared to the other ones, but it is here. All right, it is here. So you can go through and find models that you may want to utilize, and then just click on them, download them, and utilize them. And they usually have, here we go. They usually have the startup code here also. That's the best thing about a lot of these is the startup code is pretty much given to you also every time. And it's really, really great. It's really easy to get up and running. The next would be TensorFlow Hub. And that's the equivalent of the rest of them. It's just a little repo with a bunch of pre-trained models that you can go check out. So if we click on models, I believe here, this is where you can see where all the models are published. So you can go check these ones out. And what other one? I mean, and then of course you can always ask Bing, right? You can always ask Bing chat, where are some good places to get pre-trained ML models? Every cloud provider has their own services for machine learning models also, so you can use those. Oh, that's what it is, NVIDIA. All right, everyone and their dog has their own model. So the pro here for using Hugging Face or Torch Hub or TensorFlow is those ones are you just download and it's free. It's free for you to run. You accrue no costs. You can run it unlimitedly, and the only thing you're paying is your electricity costs. All right, it's 100% free. There are cloud services you can use, and surprisingly, the dirty secret is a lot of them actually aren't a lot better than the ones you can just download. So my recommendation is just use the ones that you can download for pretty much everything. Large language models, pretty much OpenAI is the best one. All right, there are alternatives like Cohere, and there's a couple open source alternatives you can look into. Hugging Face has their own version, but they're not really like that close. Hugging Faces, I believe, is they have like their own version of GPT 3, 3.5, whatever you want to call it. You can download it on your computer and run it. It's going to run god-awfully slow, but you can run it. It's going to be CPU only because you won't have enough, most likely you won't have enough VRAM to load it up on your graphics card. The last one, and this is like the pro gamer move, NVIDIA. So I don't really see many of you guys utilizing it, but it would be the NGC by NVIDIA. This is basically a massive repo they have for all of their machine learning stuff, and it is state of the art. All of this is the best of the best pretty much you can get off the shelf. Better than a lot of stuff that Hugging Face has to offer. The only downside is some of it can be a little bit more complicated to set up because it's more meant for enterprise partners. Now, once you struggle with it for a little bit, or if you're an experienced dev, it's pretty easy to pick up on this stuff and get it running. And they have everything kind of linked together real nicely where you can kind of make pipelines without much hassle, right? Without much hassle. But to get to that step is not the most fun. And they've fixed up a lot of their how-to areas. But when I was going through it, there was lots of broken code that I had to fix. But it is, again, really, really powerful. Any questions on this before we move on? Right? Any questions on this before we move on? Any questions? I don't see any questions, so we're going to chug along. So, we're going to use YOLO V8. Right? We're going to use YOLO V8. Why? Well, I just said it's not that accurate compared to the other ones, etc., etc. Yeah, but it's pretty easy just to get up and running. And a lot of you guys are going to be familiar with YOLO already. So we can just use V8. And this is all that we should need for getting it running. So let's see. let's put it to the test, shall we? So again, when you're doing something new, it's okay to make like some test files or test scripts, right? So this, I ran this a couple times, haven't ran it in a while, so let's go through just running a little test, right? Running a little test. So let's get a new folder here, or a new file, not in libs, and let's just call it test.py. And this is where we're gonna just test this real quick. So we need to pip install Ultralytics. So let's go and copy and paste and press enter. This should auto install everything else that you need, including PyTorch. I would assume Ultra already includes link environment with PyTorch. You may have to install PyTorch yourself. I'm not gonna go, maybe I'll go over that. It's super easy for PyTorch. Just click on this link and click on the buttons that you need. All right, you want the stable version, you're on Windows, right? You're using pip, you're using Python, and what version of CUDA toolkit do you have? 11.7 or 11.8? If you don't know, go download it, go re-download it. If you don't have an NVIDIA GPU, just download the CPU version, right? If you are super confused, just download the CPU version. It's the easiest one to get up and running. The CUDA one, you need to go do the setup to download CUDA toolkit, aka Google CUDA toolkit, and you need to download 11.7 or 11.8 from here. All right, you will have to, I think, does it make you sign up for an account? I can't remember. Oh, maybe not for this one. Yeah, so you just click on the download button and download it. All right, this is 12.11. This will not work. This one will not work. All right, this one will not, again, that one will not work. You have to do 11.8 or 11.7. So just type in 11.7. There we go. There's 11.7. Again, or you can just do CPU. That works on everyone. So we just installed Ultralytics. So let's see the usage right here. And let's go and copy their code and paste it. That did not copy. Let's go and paste it. There we go. So load a model. So this will automatically load a pre-trained model for us to utilize. We don't want to build a new model from scratch, so we're going to remove that. We want to use one of their pre-trained models from scratch. This is going to be the nano version. We're going to change that to maybe like, I think it's just an L for the large. Here it is. L for the large, and then X for the extra large. Let's do extra large, because again, speed doesn't really matter. All right, we're not doing real time, so we can go with the best one, the most accurate one. Using the model, we're not training. All right, evaluate the model's performance. We're not doing that either. Predict on an image. Perfect. Let's do that. And let's go ahead and print our results. We'll print it like that and see what happens. So this is going to go to this image right here, right? A bus with two, three, a half a person. So let's see what happens, right? Let's see what happens. Let's go ahead and do our Python test. And this is gonna take a second to run, because these tests take a little bit because they are loading up PyTorch, especially if you're loading up in your GPU. It may take a second, and then yeah, of course, if it has to download the model, the pre-trained model, that will take a second too. That is absolutely large. That's 131 megs. So maybe if you have a slow internet connection, don't download the large version, all right? Don't download the large version, because that is quite big, right? That is quite big. So you can see here, we just ran it and we got some results, right? We got some results. This gave us a lot of good info. So by default, the default model here will only, it says 79. I thought I had 100 different things it would recognize. All right, so there's 100 different things we can recognize here, and here is a list of all the things it recognized. All right, now it did work. This looks like a little bit like gibberish, but look, they make you work for it a little bit, because there is a lot of information in here. So I didn't even realize it gives you the speed here, which is really, really nice. So this right here are all the items that we detected. So we need to extract out what those items were exactly. There's also an alternate version of the detection model. I think it's only for the segmentation model. I can't remember right now. I'm just trying to mess that up. For their models here, I think it's just, maybe it's the classification one. It's either the classification or the segmentation one. It was trained on a larger data set, and so it knows 1,000 different items. This one is a smaller data set, so it only knows, it looks like 79 items. So I would highly recommend, you know, if you want to do, I think it was this one. I think it was the classification one. If you want to identify more stuff, all right, use one of these other models. Just know there are pros and cons. The segmentation one, very accurate. It will literally outline exactly whatever it identified. The classification one is going to be one thing for the entire photo. So if you want multiple for one photo, classification will not work well for you. So let's see here. Any other, where are the docs at? I don't want the CLI docs. Are you kidding me? GitHub, Discord, docs. All right, so predict on images. Here we go. So when we get our results, we're going to get boxes, we're going to get masks, and we're going to get probabilities, which will tell us information about every single one of these predictions. So we just want to, we don't care about the bounding boxes or anything like that right now, which you can if you want. All right, I'm not going to do anything with it, but you can if you want. Make it so when people look at your applications, you save that bounding box information, and on the website you can display the bounding box around each item that it identified. All right, so we want .probs, all right, because this should tell us what exactly is in the image and what were the probabilities of each one of those items. So we're rerunning this. List object has no probs. Okay, for result in results. I see. For results in results, print result dot probs. All right, now let's rerun that. So this is going to be an array of oh, that was rough. It's going to be an array of results according to the docs there. So we're going to iterate through every single one of the items in the results, and it looks like right here this doesn't seem right at all. 5 people, 1 bicycle, 1 bus. Were these my predictions? Because I see a none right here. I'm gonna run that again with print and some text here, because I'm kind of confused on that output, because I feel like it's just this none right here, which means probs is not what we want. Class probabilities for classification. Oh, why can't you? Yep, it is right there. Why can't you guys make this easier? Boxes, XXY, confidence scores. Let's print the results raw and see what we get on that, because I would want the labels. Let's go ahead and print the results raw. It's my favorite when there's no typing. Doesn't return anything. I want typing on this item because we can't just easily figure out what's attached to it. So here we go. So this should be for results. Where's my ASDF? There it is. This is the typing for it. So let's copy this. and put the typing there. Gonna do the typing here. List. What do you mean? I'm importing Ultralytics. Oh. From import Ultralytics. There we go. Does it really want me to? Why you gotta be like that? No? That's mildly infuriating. Okay, let's see here. Res plot. I don't want to plot these items. Really? Why can't I just get something simple here with the first example code? These bastards. Return a generator, return a list. A list would be fine. I think the results are for if we give it multiple images, but we're not giving it multiple images. We're only giving it one. So these are the boxes. Segmentation. Do we see anything here? And this is said it was a list. So let's figure out what the hell we're dealing with right here. So let's go ahead and do a type of result, and then let's also print the dir of results so we can see what exactly we can mess with on it. Let's have that print after the big printout so we can get some insight on what this item is and what our options are, because it looks like this is a potential. No, the box. I don't know if this is a dot item, like this is a class that we can do with just dot boxes, or what. Mask original image. So that's the original image. Original shape, probs, speed. Is it just not identifying anything? That wouldn't make any sense either. Why wouldn't it identify anything? All right, let's rerun this. So many questions, so little answers. Again, when you're doing development, that's a lot of times what you're going to spend most of your time on. Like we talked about before, it's going to be asking questions, figuring things out, investigating. Surprisingly, a very little amount will go to development. So we got boxes, key points, keys, masks, original shape. We can plot, save text to JSON. So it is this class of results. I don't know why the typing is not working. Whatever. Let's remove this. And let's see here for the boxes. Did we have anything? It says boxes objects. So we do have boxes. So let's go ahead and print the boxes and see what's going on. Boxes. And I think we got to do per box. So let's go ahead and do for box in result.boxes. And let's go ahead and print out the box. We can remove the boxes here. And let's see if there's any information in these boxes for us to check out. Let's see here. Quick start. Is it gonna be a quick start? I don't want to run your stupid single lined terminal thing. Alright, let's see here. We got our tensor here. Let me go ahead and rerun that real quick because it got a little messed up. Model results export Python guide. All right, so we have our boxes here. That didn't help too much. I'm about to, what's this? Confidence 43% confident on which item? If you all are seeing it, please let me know. I'm about to ask Bing to help us out with this, because I don't want to keep having to explore it right now. I thought it would be a little bit easier. Or we're about to use YOLO V5. Let's go ahead and see what Bing says. Python code for predicting and listing out predictions for YOLO V8. Let's see if we can get some example code generated for us, shall we? Because like we could, you know, save what it did to an image, but that's not going to help us out much here. Because we want those results. Yeah, we want, those are the boxes. There we go, the box label. So what we want. Annotator. We need to make an annotator. Annotator, where is this from? Annotator is from here for plotting. Box label B. What is B? B is the box coordinates, model name. Int C. C is the box CLS. The box CLS is right here. That says 0. Okay, those. Oh, okay. CLS is the prediction. All right, 0 is a human. So those are the human predictions. That's a human. That's a human. This one's whatever number 5 is. Okay, so CLS has what we want. So every box.cls is the item that we want, and we need to cast it into, so in model.names, and then we can do box CLS, and we need to cast this to an int. There we go. So now if we rerun this, let's go ahead and comment out box. I see that comment. Let me go and run this first, and I know it's a but try and problem that bot failed. Focus on human. Go away. Ask your question in the aimbot chat. And if anything else you can ask on, well, there's no more chill Q&As on Sunday, chill Q&As, because 100 Days of Rootkit is coming to an end. We might continue it. Maybe we'll do it twice a week, chill Q&As, and they can also be asked during that. Let's see here. Dict is not callable. So is the box not callable? Boxes are results dot boxes equals boxes, box and box. Is this not exactly what we're doing here? How is this not exactly what we're doing? We have R for results. We call them result for box in boxes. All right. We did results.boxes for each item. Box.cls. Oh, wait. Oh. This is not a, this is a dictionary. All right. Let's rerun that. Y'all conversating over there. Any questions on anything in regards to what we're doing right now? All right. This time it ran, and we didn't get any errors, which is good. Oh, we didn't print it. God. Always missing the simple, stupid stuff. I was like, why didn't it print out? So we're not getting errors, but we didn't print it. So now when we print it, we should see what the results are. Because what's happening for machine learning models, and this is common and a common difficulty point for people. There we go. This is all the things that I found. Well, this stuff. So this is a common pain point for people trying to get into machine learning. Machine learning models do not understand even GPT. They have no concept of characters. They have no concepts of colors, pictures. They have no concept of words. They have like human and person and bicycle. They don't understand all of that. It seems like they do, but it's an illusion. all they're being they're being fed is numbers. All right. So what's this box.cls? What is this? Why did we have to go through this complicated process in order to get the labels out? Because the machine learning model was not trained on this is a person, look at this person. No, it only knows numbers. So a person is given the number 0. All right, a bus is given the number, let's say in this example, 1. A bicycle is given the number 2, and so on and so forth. All right, everything is given a number, and then the model is trained on those numbers. It is the responsibility of the devs to then associate those numbers later on with the labels, which is what we're doing right here. All right, we're associating back with the labels because, again, the machine learning model has no concepts of this. This is the same thing as if you try to get into running your own LLM, aka like GPT. You're going to see that you get an output of numbers, and you have to convert that into characters, right? Because it only knows numbers, right? It only knows numbers. But through this, we are able to go ahead and figure out how to utilize it, right? Through our test script, how to utilize it and get all of these items out. Now, the only issue here is we don't want to potentially be adding, again, it depends on how you want to program it out. We're going very, very simple on this one for our auto tag feature, right? Using machine learning. We just want tags of each item, but not multiples. I'm kind of saying that weird, but basically we don't want all these person tags. If there is a person in it, we just want one person tag. All right, we don't want a bunch of them. So we want to basically get rid of any duplications that may show up. Very simple to do that. All we have to do is make it into a set, right? Make it into a set. So we say this is all going to be add. So we need to actually make it right here. Can we add on a set? On 1 second. I just want to see, can we append to a set? Oh, we can do add. All right. So we're going to do our set is going to be equal to results or label, or I guess technically we're going to be calling it tags. So tags are equal to a set, and then we're going to add every single one of these new items to it. And then once we're done adding all the items to it, then we're going to print the set. So the set, again, will pretty much make it so there's only one of each item in the array, right? So it's an array with only one of any type, right? So you won't get any duplications. And if any duplications exist, it will get rid of them, right? So you can see right here, we just got our array back, all right, our set array back, and we have a person, a bus, and a bicycle in that image, all right? And there's no duplications. It will automatically get rid of duplications. So this is perfect. This is exactly what we want for our tags, all right, for our tags. So we have our code here, so we can go ahead and maybe remove the things that we don't really need. So we can remove that, we can remove this. All right, this looks about right. This is pretty much the minimum that we need in order to copy this and move it over to our auto tagging feature. So I'm going to put this off to the side. I guess before we incorporate it into our application for auto tagging, are there any questions right now? Are there any questions right now before we incorporate this? All right, I don't see any questions. So if you do have questions, go and ask them. We're going to chug along. So let's go and throw this off to the side here so we can refer to it. And let's go over to our libs and our photo file. Because I believe the logic was here. I left Onyx line in and just exported the Onyx model. Yes, you can do that too. If you want to take the time to export or utilize the Onyx or TensorRT model or whatever, you can. You will get better results. Right, you will get better results. We're going just very simplistic, right? This is the easiest way to get it running on anyone's computer, all right? Again, run the CPU version of PyTorch. If you're having issues, it will work. It will be very, very slow, but it will work. So let's see here. For our photos, we're going to get the photos, and here's the file name. We're going to send the file. This is a get request. We want the post request. So when people post a new image, right? When people post a new post, here's the logic for our photo, right? So we're sending our photo here to be validated. This is where we're supposed to do our tags, right? This is where we're supposed to do our tags. So let's go ahead and add our logic here. First thing is we need to bring our import over. So let's go ahead and bring our import over. Next, we need to load up the model. Now, I highly recommend doing this either in the init right here or right here at the beginning. So that way the model loads only once at the very beginning. If you do it here on the request, it will reload the model every request, and you saw how long it takes to start everything up. It takes like 30 seconds, right? So it's gonna be, if I send a request for like making a Facebook post, I'm gonna wait 30 seconds for, no. All right, so just put it either here, all right, and make it a global variable, or make it a part of your class here. So let's just make it a part of the class here, and let's say this is going to be our YOLO model, right? So that's what we're going to call it, YOLO model, which is different than model in here. So we're going to need to change that a little bit. So now we need to do our prediction, all right? And so right here, so I'm using a 3080, and it was taking, I believe from the stats, it was taking like 3-4 seconds to do your prediction. All right, so again, machine learning models can really bog down your stuff. Self dots, YOLO model, there we go. So the URL here, we don't need this to be a URL anymore. We just need this to look at our image on our local system. So you can just do that by saying this file location. So let's go ahead and extract it out and say file name equals, all right, and then we can remove that. So that way we have stuff dry, so it will be saving it, file name here, and this will also be looking for the file name here. All right, so we're going to get our results. Now we need to grab our tags out. So this is going to grab our tags out. We want to move this tag set out of the for loop so it's not scoped in there. So it will be like that. And we know we are always going to run just one image, so we will never have multiple results. So if we want, we could just hard code results 0, right? We could just do that. I think this may actually cause it to crash, because if there's no results, it may not work. I'm not quite sure. So for safety reasons, I'm just going to do it like this, because it will never hit this unless there is a result. All right, so this needs to be changed to YOLO model. All right, so our tags are going to be added. We don't need to print our tags anymore. All of our tags are going to be a part of this tags variable. And it looks like we kind of wrote the code here earlier for adding tags. So it might be actually good to... no, because I was going to say we can move this logic into this for loop, but we don't really want to do that because we're going to be potentially adding multiples of the same tags. So we'll just have this run first, and then we'll do a for loop, so for tag in tags, and then we will add these. So it's going to be, we need the photo ID, and then we're going to need the user ID, and we're going to want, come on, what's the last item here? Photo ID. So this just wants photo ID and tag. All right, so let's just do photo ID and tag equals tag. All right, so this will be adding it and committing it. Fixing the chicken and the egg problem. All right, this looks about good, right? The only thing is we kind of want to see our results, so we can just check the database, right? We can just check the database. So let's go ahead and run this, shall we? And let's see if it works. Any questions before we move on? I'm going to ask your questions. I'm going to go ahead and start this. There we go. Let's pull up Postman. Let's choose a different image for our post. We can just use this bus image they sent us. All right. So let's let me delete this. No. Yeah, I'm just gonna delete it. We're gonna go find that site that we used earlier. So image to, what is it called? Base 64. Image to base 64. This is definitely a different site. Hopefully it works just fine. Let's go ahead and get an image here. Let's get a good image of, I don't know, CSGO. All right, images. This one works. We'll go with that one. Let's go ahead and I think I have to save the image. So let's save the image. Let's choose the image. Encode image to base 64. It doesn't seem right. Whoops. All right, I'm not gonna judge it. I'm gonna click on copy, and let's go over to Postman. I'm changing it from the logo because the logo I'm pretty sure won't pop anything. So let's paste that. This does not look like base 64. This does not look like it's gonna work. I'm gonna run this actually through something else because I do not trust this. This does not look right. Yeah, this is the one we used last time. So let's go there. Base 64 image sort encode. Base 64 encoded. Okay, maybe it is. I don't know. It looks a little fishy to me. But whatever. We're gonna move on. Let me go ahead and just replace it just in case there's anything different. Doesn't look like there is. All right, so we're gonna make this post and we're gonna be like, please tag this post. Right before we send this off, I want to pull up the database. All right, we're going to go to photo tags. We're going to see there's no tags in here currently. All right, and this is our only way of verifying if the tags work because it's not going to return any data to us. So let's go ahead and press send and see what happens. Now again, it's using machine learning now, so this time it's going to be a little bit longer on the send for the results to come through. And it looks like we have a duplicate entry for the photo tags, which is interesting because it's working. It worked. All right, we have baseball bat here. So it found a baseball bat in that image apparently. I don't remember there being one, but let's see what our SQL issue here is. Let's go ahead and pull up the code. And let's close this out because we don't need that anymore because we know our post is working. We are going to photo tags equals tags. We're going to commit photo ID. Did we accidentally make this a... Ooh, that's the issue right here, is we made this the primary key because we were following the auto-generated code, but that added a little oopsie for us. So we're just going to manually fix the database, right? Ooh, so we can see a tag is right here. We're just going to manually fix the database here by going to this, and we're going to turn off it as a primary key. And I don't think we can do it like that. I think we have to go over here to constraints, and let's go ahead and delete this and save. Persist. Foreign key constraint is not correctly or is incorrectly formed. Well, I'll just delete that one too. All right, we're just going to delete the entire photo tags table. All right, we're going to delete the whole photo tag. We're just going to have it regenerate. All right, we're just going to have it regenerate the photo tags table. Could not assemble any primary keys for the map. Okay, whatever. If you really want a primary key, we'll give you a primary key. There you go. Are you happy now? All right. Now, can you start, please? There we go. So now it's all started. Let's go ahead and repost this. And it should work perfectly now. There we go. We got our result back. Our post completely went through. It's about 6 seconds long, right? Because we're using that machine learning model. Now, the first run of a model is always the slowest, all right? It's a cold run, a cold start. So if we click on send again, this should be faster. And as you can see, it was significantly faster, right? The first run of a model is always slow. So slow, in fact, that it's actually common practice when you start up your model for doing machine learning, you'll actually auto run some dummy data for it to analyze just so you can get the cold start over with, right? So if we go over here to our database and refresh, we should see a bunch of tags in here, all right? This is for the photo. Let's go ahead and refresh the database so we can get our photo tags. Here we go. And if we look here, we can see we got person and baseball bat. All right, so it's finding at least one person, if not multiple people in these photos, and a baseball bat. So let's go ahead and re-look at what our image was, which is the CSGO one, and it's identifying the AK and shotgun as a baseball bat. It looks like, because I don't see any baseball bat in there. But the main point is it is working, and this is literally how easy it is to get machine learning incorporated in your applications, right? Just that easy. We didn't train any models. We didn't have to do any craziness, all right? Yeah, there's some investigation on how to get, you know, the data out of the model that we wanted. But besides that, that was easy. And you can easily, like I said, you can easily expand upon this by making more columns in here, maybe one to store the bounding box information. So when these images are loaded on the website, you can draw bounding boxes right around the items that you have identified. I think sites like Facebook does that, and I guess does Instagram do that? I know Facebook does for people that it identifies, or you tag in, it will draw the bounding boxes. All right. Any questions on this? All right. Any questions on this? Very interesting what you are doing, says is dev. Well, we got 90. What day are we on? It doesn't even say on Twitch what day we are on. Did I forget the... Oh, I forgot to label... I forgot to label the freaking... the thing. This is part of our 100-day rootkit event. So there's 90-something other days that you can watch. They're all recorded on our YouTube channel. And it's all for you to learn everything you need to know to get our comp sci cert. So learn, get our comp sci cert and get a job. Any other questions before we go on break? Right? We sped through that because, again, like I said, machine learning is really, really easy. All right, it's really easy to get a model and just start using it. All right. And this is probably like the quickest little run we did here. So we pretty much have completed this, right? We've completed this. Again, YOLO is the bottom of the barrel when it comes to analyzing stuff. You can use a more powerful model that has potentially thousands, all right, thousands of things it can detect. You can use something like, I don't know if Detectron, I don't know if how Detectron stacks up to everything else right now, right? But it used to be one of the better ones a while ago, and it can identify a lot of different things. I think it can do, don't quote me on this, all right? It's been a while since I've used it, but I think it can do 10,000 different items for its identification. Let me see here if I can find it real quick. I guess if we go to the layers modeling, I don't even know where it would be. Can I go to the repo? Where's the repo link? There we go. And on GitHub. All right. So I don't see any questions. So we're going to go on break in 2 seconds. I can't, I'm trying to remember on the top of my head where I would see where all of the listed items are in regards to what it can find. Whatever. You guys can verify that, what I said there. But let's go ahead and go on break. So we'll be back. How long will the break be for? Great question. 3 to 5 minutes. 3 to 5 minutes. So we'll be back in 3 to 5 minutes to continue on our journey here. All right. So I'll see you guys in 3 to 5 minutes. Go to the bathroom or something. All right. Let us get back into it, shall we? Let me see if there's any questions. All right, I don't see any questions right now. So if you do have any questions, go ahead and ask them. All right, go ahead and ask them and throw them in the chat and we will answer them. Before we get back into it, just so you guys know, we are Rootkit, nonprofit organization here in the US of A. Don't go to college. Don't go to any other boot camp. All right, you're already here. You're already watching. I know I messed up on the label. All right, this is a part of the 100 Days of Rootkit event. On YouTube, there's the past 90 whatever days all recorded. Watch them all. Learn everything you need to know to get our comp sci cert and get a job. It's really that easy. All right, we're going to help you through every bit of the process if you get certified. All right, you can go check out all the perks right here. On top of all this free greatness we're doing, all right, you can go over to our blog. And we have our final giveaway going on because everything wraps up on Friday. So go enter to win. It's free, right? It's free. Just click the button and earn entries. You get more for subscribing to our YouTube channel, following us on Twitch, etc., etc. We're pulling 10 winners for the last one. 6 will receive sweaters, and everyone, including the sweater winners, will receive a bunch of other merch. All right, we're kind of just trying to dump the merch. So go sign up right now. Right? What are you waiting for? Additionally, if you're watching on YouTube, there's a link down in the description below. If you're on Twitch, there's a link somewhere. All right, somewhere for this. We are a charity, all right, here in the US of A. Avoid your taxes, right? No one likes taxes. Avoid your taxes today. Donate. Depending on how much you donate, you can unlock certain rewards like our epic stickers, our collab t-shirt, and our epic sweater. All donations are being matched 1-for-1 for the first 10,000 donations during our event. Additionally, we have pillars along the way, like streaming for 24 hours straight, shaving my head, and the one no one wants to see, all right? Shaving my beard, all right? No one wants to see that, all right? All right, that is the conclusion of our intro. Are there any questions, comments, or concerns before we chug along? I don't see any. Oh, and lastly, we are in the Discord. So if you go ahead and jump into the Discord, you can jump into the events chat and talk. You don't need to just type in the normal chat. You can talk and ask questions at any time. If you are a volunteer, aka a champion, a Patreon member, or a server, Discord server subscriber, premium, whatever this stuff is called. All right, let's see here, one last check. So we, just to conclude what we did earlier for the last hour, we finished up with our task here. All right, automatic image scanning and detail extraction. So on our little post function here, again, people can post just straight up text or include an image, right? Or include an image. We showed how we can use base64 to send that image to a REST endpoint. Now, this is one of many ways you can go about doing it. And it's up to you on whether you want to use this or not. But on top of that, we then showed how we can easily incorporate pre-trained machine learning models like YOLO, or use things from Hugging Face or Detectron or whatever you want, and add them here to empower your application, to add machine learning to it. And these are free. Download, use them. They're free for you to use. It's not like you have to go reach out to an API somewhere and pay money for every image that's scanned. No, it's free, right? So utilize it, right? Utilize it. It adds so much extra power. And again, spend time on Hugging Face, right? Where is it? Spend time on Hugging Face. Do you understand what a image-to-image generator is? No? Go mess with them, all right? Do you know what visual question answering is? No? Go mess with them, all right? Go to each one of these categories and mess with them and see what is available. Let your mind be expanded in what you can potentially do for your application and empower every single application you make. See a question: why do you try to do tag detection right in the request? Isn't that real slower down in a blocker as well when you think concurrency? Yes, you're 100% correct. You're 100% correct. So this is for the final project, showing some stretch goals here. Basically, this is going over potentially what you could be given on our practical exam for our certification, and then some extra stuff that you don't need to know in order to pass it. It's kind of stretch goals to learn. This is a blocking function, all right? This, as you guys saw earlier, on a cold run will be like 6 seconds, and that's running on a 3080. And then after the cold run, it's going to be more like 1.2 seconds, right? Not too acceptable. It's fine. It works, but you may want to have speeds that are faster. So it would be ideal. It would be more ideal if you set up, again, we're training people for basic comp sci cert, for entry-level jobs, all right? This is fine if you're entry level. Your stretch goal, if you want to make this a little better, would be thread this process or spin off a separate pipeline that will do this post the image being uploaded. So effectively, you would want to add the text to the database, save the image, and have this start kicking off a separate machine learning pipeline that will do the analysis of the image after the fact, right? After the fact, not in line here. If that doesn't make sense, don't worry about it. You'll learn about this stuff on your job, right? You'll learn about this stuff on your job. And if not, we can do some classes here at Rootkit to show you guys some of these pipeline mechanisms you can utilize, go over some of the Apache repos that you can use for doing a lot of these things. But why teach them then logics which should be avoided at all costs? Because you have to start from somewhere. You have to start from somewhere. So this works, and all that matters at the end of the day is that it works. All right. Yeah, because no one out of college is going to be learning entire pipeline infrastructures and how to incorporate with them, because again, like something like like Spark, you know, not everyone's going to be using Spark, so it's better just to know the base concepts, and when you go to your job, you'll learn whatever pipeline mechanism they want to utilize. All right. Everyone and their own dog also has their own opinion on each one, especially if you're using cloud services. Depending on what cloud service you're using, you may have different pipelines. You know, AWS has their event bridge, so maybe you're using that. Maybe you're just using SNS. Maybe you're just using normal Kubernetes with what is it called? I'm forgetting the name right now. So it distributes your messages across. Maybe you want to use Spark instead. Maybe you're using RabbitMQ. There's so many different things out there, and it doesn't really matter. It doesn't really matter. What matters is you know how to incorporate these things. Let me learn about job queues in college. Well, look, we've learned here that European colleges may be having quite a lead amongst the American colleges, but again, the concept is fine, but in reality, utilizing it not really work. There's so many other things that are more important, like your data structures and getting practice with your code. Again, this is for a base level 2 cert. For the level 3 certs, those are things you're going to need to know, right? Those are things you're going to need to know. For more context, you can watch all the previous 90 something days, right? All right, so let us continue on here, shall we? So on our README, we can go ahead and check off our automated images, right? We can go ahead and check off our automated images because we have it completely set up. It wasn't too difficult to get that going on. So next coming up, we have our commenting and our like functionality. Now, due to time, I don't think we're going to do the comment system, right? So we can do likes instead, right? We can do likes instead. So let's check that out. To do likes, we can spawn off a new table to do our like mechanism. Some people may initially think that doing our likes on the post itself might be sufficient. It could be sufficient. It depends on how you want to go about it. Doing a separate table for your likes, I would say, is going to be better overall, because now you can easily log every person and who they liked or what they liked, you know, each post that they liked, and have them as separate line items, and then you can go query and get all of those line items to get the total amount of likes, but also see every single individual who interacted with that post. All right, so that's why we use potentially a different table for it. So first thing is we're going to need to make a new table for it. So that means we need to go in our DB here. And second, we need to then make a new endpoint for our liking system. So let's go in here and do class, and we're going to call these likes db.model. And we're going to go and put an ID on this because it was not happy before. And user ID is perfect. And the next thing we want is going to be the post ID. Perfect. And that's pretty much all we need. You can expand upon this. So effectively, if there is a record for you liking something, that is increase 1 for the like on that post. You can potentially add a new item in here for if it's active or not. All right. I guess you could also do some logging for like created at. I wouldn't call it disabled. I would call it, I don't know, maybe active. This purely is if they dislike it, you can keep track now without deleting the record. You can keep track that they not disliked it, but unliked it. But also you're keeping track that they interacted with it, right? Because when you are looking at metrics for stuff behind the scenes in Google Ads or YouTube Studio or etc., they have these concepts of impressions and other just various advertising things. I'm not an advertiser, so don't quote me on all those. You can still unlike stuff, but they're not going to delete the record. They're not going to delete the record that you just didn't perform that action. They're going to keep that on record forever. They're just going to show that you kind of toggled it off, right? So this is something you could potentially do also, right? We're just going to keep it very, very simple for right now. I guess we'll just keep the created at. We're going to keep it very, very simple right now and just have it so if the record exists, you're good. If it doesn't exist, all right, it doesn't count as a like, right? Super easy. Now we got the likes table all set up. Now we can go and make a new file in here called likes.py. And let's go ahead and go to like from our photos, copy. We also need isAuth. So copy, let's paste. Let's do our class. Let's go and copy right here. There we go. And let's get our likes endpoint going on. We're going to want to make this a post. Technically, I believe it should be whatever. All right, Snow can get mad at me later. I believe it goes like puts are supposed to be for creation of new items, and posts are supposed to be modifications, or it's the other way around, right? Again, you can do whatever the hell you want, but there is a more proper setup for the endpoints. I'm gonna tell you right now, a lot of companies don't follow it. A lot of companies don't follow it, all right? So let's see what it auto-generated here for us. User header and JSON request. The request, user ID, that works. We can get the post ID out of the request too. That works. And then we can make the post. This is me querying the post. Likes post.like. All right, this tried to auto generate some stuff, but this will not work for us. This will not work for us at all. So we can have it so they send the post ID, and when they send the post ID, then we can create the post, and the post is going to be our user ID equals user ID, and post ID equals post ID. Let's go ahead and do a sanity check on our DB over here. Let's throw it off to the side. And there we go. We got ID, user ID, post ID. User ID, post ID. Perfect. So now the post is created. Now we just need to do our commit, but also self-db.session add the post item. So that will add it. This should be good. We don't need this. We could return a success. So we could just say success or message success. All right, so this is for now posting a like, so aka the like went through. And then we can also do a get request to get all of the likes on the post. Should that be its own endpoint, or we can merge that data in the post? You missed the post model with likes model in that file, because post should already have been created there. Kind of confused on that you mess up the post model with the likes model in that file? I'm kind of I'm not quite sure what you mean there. But let's go ahead and continue on. So for our likes, when we want to retrieve all of the likes, we could, let's be very generous, I guess, with our data. Let's be very generous with our data. So we're going to have a separate endpoint here for retrieving all the likes, and we're going to just dump all of the likes to the front end, so the front end devs can decide what they want to do. All right, because you know, you've probably seen on Instagram or TikTok or wherever else that when people like something, you can usually see if some of your friends liked it. You might see their little icon around it. So we'll let the front end people kind of decide what they want to do with all this data, and if they want us to modify it later on, they can make a request and we can, you know, trim off some of the fat of the data that we're dumping out. So let's go ahead and do a @isAuth. Let's get our get request going on here, and now we're going to there we go. We're going to want to do we're going to get query params. We want the post ID. This would work. We could limit how many things are no, we're going to remove the limit, so there's no limit on what we return, so they're always going to get the total back. We could also modify the logic so that it returns a limited amount of people that liked it, so maybe only 10 people's user information is handed forward, but it also returns to you a result of exactly how many people total liked it. That's totally up to you. We're going to keep it simple right now. We're just going to dump everything. All right, we're just going to dump everything. So let's go ahead and remove this. Post, list post, not sure why this is here. And if the post ID is none, we want to definitely do our return, and there we go, invalid request. Let's go and remove this logic. Let's see if this is going to be good for us. So we're going to do self, we're going to query on the post table, we're going to look for the post ID, and we're no longer going to limit, we're just going to grab everything. So now that we got everything, not on the post table, over in the likes table. So we want to get all the likes in the likes table based off the post ID. Once we have all of that, we have the user info. So we'll let the front end people deal with it, because if they want we won't enrich the data here. We'll let the front end people decide what they want to do. If they want us to auto enrich the data, aka grab all the user information and pair it in the return that we do here, they can let us know. Or we can just send them the IDs of everything, and then they can query the user endpoint to get the user information for each user that they want. All right, so that way we're not sending too much insanely large amounts of data right off the bat. So for this, we're going to get our results. And we're going to, this should work right for P. This is copying from our stuff earlier. Our results to dict. Would this work? I can't remember the exact layout right now. Let's check on the, it's going to return, oh, that's right, it's going to be in the class automatically, so it's going to be a list of that class. So we have to add on our class here. So this is going to be a list of our likes class. So for like result, so this is going to be likes. So for like, in likes, we're going to do our to dict, which we need to create. So let's go to our likes object here, and we need to utilize our other likes object. So let's go ahead and do from libs dot, we already have it up here, and let's go ahead and do our likes. And we're going to have an issue here in regards to our endpoint, so we'll call this likes endpoint for now. We can change this label later as we see fit. So likes are going to be here, and we need to go to our likes and we need to add a to dictionary item. All right, just like we did here up above. So we're going to do it def to dic self, and there we go. Perfect. So now that we got that, this logic should be completely done now. Just one last glance through our data. So this is going to be to dict. This will give us our data. So we should be getting a list of all of the likes. So let's go ahead and test this out, shall we? So let's load up Postman here. Let's go ahead and make a new folder for our likes. And let's add some requests here. First, we got to do our post request so we can add a like. So let's go ahead and change this to add a like. Let me see here. URL / and we want the likes endpoint, which we haven't added yet. So let's go ahead and go to main, and let's go ahead and do our likes endpoint. So we can like stuff through our like mechanism. Import libs.likes. Import libs.likes.like endpoint. And that should be good there. This is up and running. So we're going to go here. We're going to say like. This is the post request. Now in here, we got to do our body, and it was JSON. And all we have to do is say the post ID. So let's go ahead and say the post ID that we want to like. So let's see what posts we have here in the database. So we have post ID of 1, 2, 3, and 4. So let's go ahead and like the first post, shall we? So we'll just say we want to like the first post. Let's go ahead and send this, and we have an invalid request because I believe we're missing our, no, that should be in there, our authorization token, unless it went bad for some reason. Let's go ahead and check out here what the issue may have been. Let's go to our likes and see our post. So invalid request for an exception. This is going to be post, which is wrong because this should be for our likes. Like. Why is this all types of messed up? And we're gonna put that right here. All right, that should work. I just realized that likes is plural and it should be singular. So we're gonna have to modify that later on to be singular. So we're getting the 400 error again. User ID, user ID. So let's go ahead and print out our exception here so we can know what's going on. So as E, print E, and let's see what our exception is. Insert unknown column created at in fields list. Did that not show up on the database when we created? Did the likes table even get created yet? I think we have to restart. No, it did. It's right here. Oh, we created the likes table and then we modified the likes table. So let me go and delete the likes table, and let's go ahead and restart the table. Actually, before we restart, we can go in and just fix that pluralization issue because I don't really like that because it's only for one. That we did that pluralization issue here also. We won't fix that one because we've already moved on. But again, naming. All right, so we're gonna change that to like. We're gonna change this to like. We're gonna change this to like, and this will be likes. There we go. And now we can call this likes. And we can change this to be likes. Perfect. So let's go ahead and rerun this. This should create the table again. And we can go ahead and test this. It should work now because all of the proper columns will be in place, unlike they were before. And look at that, we have success. So our like successfully went through. If we go over to our tables here and let's refresh the database, we have a like in here and you can see that our like successfully went through. So user ID of 1, all right, went and liked post number 1. We can also then go through and say that we want to like post number 2 and we can send that, and now we liked post number 2. We do have a bug though in the code right now, because if I want to like the post again, it will let me like the post again, and you'll see in the database here that we have 2 records now of us liking the post, right? So that is a little bit of a bug. So we're going to want to make some logic to do some checking to make sure that we can't like the post twice, right? So let's go ahead and check that out. Before we do though, let's go ahead and do our get request test, just so we can see that in action. So let's go ahead to Postman and let's do get likes. So add a request, get likes, URL /like, and this is going to be with a query param of post ID, and then we got to say what post we want. So we're going to say post of 1, and there we go. Now we got all the likes. So it's just that easy. And when you receive this on the front end, you would just do a length of, and you can see how long it is and then get your total. Additionally, we could modify this, which maybe we should on the back end, to just be results. So we can do here in data is, this will be, that's a list of likes, and we'll change this to be likes are going to be that, just to ensure that was correct. Let's do there, and then comma count. Perfect. So that way we can save the front end a little bit, and they don't a little bit of compute. They don't have to calculate every time on a load the amount that's there. They can just look at the counts and see the counts, right? Because again, the server, you can offload all this stuff to the server. So let's go in and fix that bug real quick that we have for the unlimited liking, and we're gonna call that good. We're gonna call that good. So I think in regards to fixing this bug, what we're gonna do is, if they send a post request, we're gonna check. If they've never liked that before, they're going to be added, and it's gonna be a like. If they already have added and liked it, then we're going to just remove that, and that will turn into it being, what do you call it? It being a dislike. So basically the same function for liking and disliking, all right? Basically a toggle switch. Any questions, comments, or concerns before we chug along here with our last little bug fix before we call today a day? All right, I don't see any comments, so let's go ahead and continue on and finish this up. So we have our post going on, and immediately we're just grabbing the data that we need, and then afterwards we're going to try to create a like and then add it to the database. This right here, we need some logic beforehand to see if there is anything already in there, right? So let's see if we can actually get it to auto-generate here. Excuse me. So check if user has already liked this post. Perfect. So we have our query here where it will query the database for that user ID and the post. All right, and we're going to get the first item there. So if this comes back with something, so if like is not, so if it is none, If it is none, there's nothing there, so we want them to like the post. Else, that means something is there, and we want to remove their like. Perfect. So this should fix the issue really easily here. Now, I can't remember if this throws an error if it doesn't find it, or it I don't know. We'll see here in a second. So let's see. So this is an issue right here because we have 2 likes. So we'll always have 2 likes in here. Actually, no, it should auto correct. It should auto correct. So let me go ahead and do get likes again. So the same user number 1 liked post number 1 2 times. All right, little bit of an issue, but with our new logic here, this should be a little bit self-correcting if they're trying to spam like on it. So if we try to add a new like to post ID 1 right now, it should auto remove one of those likes. So if we go to get likes now and get, look at that, it auto removed one of those likes because we already liked that post. And since we already still have a like here, if we try to like this post again, it will auto remove this like also. So let's go and run this again. Bam, success, which means we have no likes on this post anymore. Now, if we do like this post, bam, you're going to see that our like shows up. So now it's a toggleable feature, all right? We can toggle our like and we can toggle our unlike. So it's really easy to make that adjustment. Again, showcasing the power of using something like SQL Alchemy in your code. Again, as you guys saw, the setup, a little rough, right? But the power is there. It's insane. It's great, right? It's really powerful and it's really awesome to utilize. Any questions on that, right? Any questions on that before we conclude today? And yeah, let's go ahead and finish up with our git commits here. So I'm going to check off likes functionality. So tomorrow we're going to do user searching, and for time reasons, we're not going to do friend requests. We're not going to do friend requests. All right. We'll do user searching, and we're going to skip the stretch goal, and we're going to get straight into the web development because we only have 4 more days left. So tomorrow is going to be for user searching, which means we have 3 days to do the website. We're not making anything fancy or anything crazy. We're just going to get something functioning up and running. All right. It's not going to be something you want to go show off to your mom or anything. All right. But it will work. All right. And that's the whole concept, is showing off the completion, right? The completion of everything. Any questions? Let me go ahead. As you guys ask any other questions, let me go ahead and add this. So git status. All right. And just make sure this is the right branch. We have some things we don't want to push up: our test file and our PT. So let's go ahead and add this here. It's test.py, and we want anything that is a .pt to be ignored. Come on, ignore it. There we go. All right, so let's go and git add all, git commit, and now we did a lot for these for this last little bit. So added ML for auto tagging and liking. Perfect. I don't see any other questions. So again, as always, if you guys do have any questions, go ahead and jump into the Discord and put your questions in 100 Days of Rootkit, and we will answer them. All right, we will answer them. That's all I got for you guys today. So I'll see you guys tomorrow on the next one.